yellow, or when you see 2 whites, 2 reds. This project involves trying to understand how pilots interact with the interface of the 737. We're particularly interested in trying to figure out ways we can redesign or show information to the pilots that will help reduce their workload.
Industrial and Systems Engineering, which is the department that I am in, is really well poised to do research in this area, given that we focus a lot on the human factors aspect, trying to also understand the systems approach to things. So our major goal is to design systems, products, and services so that people are safe, that they're efficient when they're working on it, and that they're overall satisfied. This project is really focused on pilot workload. And the industry right now is considering going from 2 pilots to 1 pilot. And so to do that, they have to understand during what situations do pilots have the most workload. And right now, the majority of the workload is associated with takeoff and landing. That's the situations when both a pilot and a co-pilot needs to attend to the displays, attend to the environment, and try to understand and have to react if something goes wrong. Esterline is our industry partner, and they have been fantastic. They're actually the ones that have donated this 737 flight simulator. They design a lot of stuff with regards to the cockpit. They do a lot of the sensors and the controls. And one of the things that they want to be is the leader in the systems that we put into these cockpits. And that includes how the user, the pilot, interfaces with the system, and to make sure that they are specifically looking at the most important things at the most important time. There are 2 students that work with me on this project. One is a PhD student, another one is a master's student. They have day-to-day interactions with the company Esterline that we work with, and that has been truly wonderful for them. They're actually very involved in everything from the beginning of designing the scenarios all the way to data collection.
Yeah, so it's flying itself right now. It's not following the vertical profile, but I'll handle the vertical profile myself. So the end result would be sharing this with our partner, Esterline, as they design a lot of the components inside, cockpits, from, the top panel, all the buttons and displays here, to the displays that you see right here with all the digital displays. So whether it be that they are going to switch around the configuration to put more pertinent buttons and more pertinent switches in closer locations, or trying to redesign how these displays are shown so the information that is needed in certain situations is there for the pilots. They don't have to go around hunting for it.
If we didn't have this opportunity to do the research, then how we actually design the interfaces, how we look at workload is based anecdotally on what the past data shows.
It's a big learning process. So from my point of view, through a research project like this, I personally learn much more from this than just through taking classes. I think what is really great about this is that it's a very applied topic.
So to be able to work on a project like this, where we are, working with industry partners and trying to push research into application, to be able to change a widely used aircraft like the 737 that could affect, millions and millions of travelers around the world, to make their travel safer, to, trying to by reducing the workloads of pilots is very important to me.
That the JCATI funds, because it's seed money, it provides an opportunity for us to start talking about research that we can do moving forward. It's been a fantastic partnership. I really have enjoyed working with Esterline. It is truly a company that if it wasn't for the JCATI funds, I would have never even interacted with.
One day we're hoping that we're going to have some of this technology that we pioneered for will be implemented in the reality and in airplanes.